said in the last video, the major goal of this section is knowing how to recognize an equation as a quadratic function and then graphing the quadratic function or parabola by hand, okay? Once we have the parabola graphed, we will identify various attributes of it, things like the vertex, the axis of symmetry, the domain, the range, where it's increasing, where it's decreasing, where it has intercepts, and so on and so forth. Okay, so at the bottom of page 1, we're going to talk about how to go about graphing a quadratic function or parabola. It says to graph a quadratic function, use one of the following techniques. Number 1, make a table of values. Okay, so we've done that before in this class. Okay, so remember what that means. If you make a table of values, you set it up like this, a little t-chart. You get to pick the x value, okay? And then once you have your x value, you take each one, you plug it in to the original function to get the corresponding y value, and then you end up with a bunch of x-y pairs that you can plot, okay? For parabolas, this could be difficult to do because you don't know where your parabola is centered. So you'd have to ultimately use the vertex formula to figure out where your parabola is centered. And then maybe, you could go about doing it this way. Okay. If you had a parabola, for example, that was centered way out here at x equals negative 100. Okay. Usually when we make a table of values, we pick things like -2, -1, 0, 1, and 2. Okay, and if your parabola is way out at -100, you're kind of wasting your time. Okay, so while you can make a table of values to graph a parabola, it's not the most practical approach. Okay, all right, let's talk about the next procedure you could use. Okay, in number 2, it says you could apply, if possible, one or more transformations to the graph of f of x is equal to x squared. Refer back to section 3.5. Okay. Well, in section 3.5, we learned various rules of transformations to a parent function. Okay. So since we're dealing with a quadratic function, your parent function would be the basic function x squared. Okay, so, if you were given this quadratic function, x minus 2 squared plus 1, okay, if you were to multiply out the x minus 2 squared, so basically x minus 2 times x minus 2 plus 1, okay, if you were to multiply this out, you could easily recognize this is a quadratic function. Okay, so since it's in a nice format, we could actually recognize the transformations here. You would take the graph of x squared, and since you would start inside the parentheses, you're subtracting 2, so we would go to the right, we would take x squared and we would move it right 2, and then since we have the plus 1 on the outside, we would go up 1. Okay, so you would take each point on x squared and move it right 2, up 1, and boom, you'd have your parabola. The problem comes when you are given a quadratic function where you can't recognize your transformations. So, for example, if you had 2x squared plus 3x plus 4, okay, I don't know what to do with this. It's not written in a format where I easily recognize transformations. I don't see anything indicating that I need to move right or left, or I need to move up or down, or I need to do a reflection. It's too hard to recognize. Okay, so if you have an equation that looks like this, using transformations is not going to help you. Okay, the best thing you can do, the most practical approach to graphing a quadratic equation comes in number 3. Okay, so technique number 3 here. Okay, so I'm going to go ahead and highlight it here. Okay, this is the most practical approach, as you can see with the asterisks. You're going to determine whether your parabola opens up or down. You're going to find the vertex, the axis of symmetry, and the x and y intercepts of the graph. Okay, these are all things we're going to be able to do pretty easily. Okay, and then you're going to use all that information, put it together to graph the parabola. Okay, so we are going to approach graphing parabolas as outlined in technique number 3. Okay, so in the following pages, there are a handful of examples of doing this. Okay, I'll go ahead and move over to page 2. Okay, This is how I'm going to lay out such a problem. If I want you to graph the parabola and then, describe its various attributes, okay, you'll get the function at the top, okay, and then there will be some, in part A, we will start doing some work here. We're going to find the vertex, the x-intercepts, the y-intercept, and the axis of symmetry. This is all the information we need to make a good picture of the graph. So once we compute all of those things in the boxes, we will go down and graph the parabola on the grid. Okay, once we have the parabola, the picture of it, we'll be able to identify its domain, its range, where it's increasing and decreasing. Okay, so that's what we're going to be doing. This is the goal of this section, to be able to do something like this. Okay, and like I hinted at in a prior video, okay, we're doing section 4.5 next. Okay, section 4.5 is solving quadratic inequalities. Remember, an inequality is a statement that has greater than or equal to, less than or equal to. So in this packet of notes, part C in all of these problems, I am going to be setting you up for section 4.5. So that way when we get to it, it will not be that difficult to pick up. Okay. Basically, to solve a quadratic inequality, you basically have to look at the graph of your parabola. Okay. So you can see here in part C, and we're about to do this problem, you have a quadratic inequality. You've got the less than or equal to, that's an inequality symbol, and we're trying to solve it. Okay, you're trying to figure out for what values of x is this statement true. Okay, if you look at the non-zero side, that is a quadratic. You have the highest power of x is 2. So you've got something quadratic coupled with an inequality symbol. Okay, so you're just trying to figure out what value or values of x make this statement true. That is a quadratic inequality. Okay, so in the examples that follow, okay, this is what we're going to be doing for each quadratic function that we encounter.